Hello class, this is our lecture about the colligative properties of solution. And if you want to download this PowerPoint, kindly click the link below of this YouTube video. And the basis of this PowerPoint is from the Chemistry, the Central Science by Theodore Brown, Eugene D. May Jr., and Bruce E. Bursten. Okay, it's actually part of the properties of the solution, chapter number 13. Now, the scope of our discussion for this lecture is all about the colligative properties of solutions. Uh, Namely, the colligative properties are the vapor pressure lowering, the boiling point elevation, melting point depression, and osmotic pressure. And we will also tackle the colloids before the end of this lecture. Okay. So what is the colligative property or what are the colligative properties of solution? It is only dependent on the number of solute of, or particles, solute particles present, not on the identity of the solute particles. We will not consider its non-polar interaction with the solvent with regards to the solute, but rather to the number of solute particles present. And these are the four. Now let's go on the first part, which is the vapor pressure. Okay, vapor pressure is defined the pressure exerted by the vapor. But of course, the solvent alone has a higher vapor pressure. But when you add a solute particles, as you can see here, based from this equation, the vapor pressure of the solution is lower than the pure solvent because the solute is now interacting with the solvent, and the intermolecular forces is also considered. And as you can see here, the higher concentrations of non-volatile solutes make it harder for solvent to escape to the vapor phase. And the equation for this is this one, also known as the Raoult's law, by which the XA, or let's suppose that we have a solute A. Okay, now to calculate the vapor pressure with a specific amount of solute of the solute, we will have to use this equation, which is the XA, or the mole fraction of the solute, and the P naught A, or the normal vapor pressure of the solute at a certain temperature, and it is always constant. Okay, it is always constant. And take note that this is one of those times when you want to make sure you have the vapor pressure of the solvent. Okay, now this one here is just a calculation, and we will be dealing this one to the part 2, our colligative properties of solutions. So we will skip this part and let's continue to discuss the principles regarding about the colligative properties of solutions. Okay, the next one here is the boiling point elevation and the freezing point depression. And as you can see here, that the non-volatile solid-solvent interactions cause solutions to have a higher boiling point and lower freezing point than the pure solvent, as you can see here from this phase diagram. And by the way, the phase diagram is the y-axis is the pressure and temperature that is plotted for a specific substance. Let's say for I don't know what kind of phase diagrams this or this one, but it does show the relationship of pressure and temperature and the phase of what phase of matter that currently undergoing at a specific pressure and temperature. And this one here, this is one here, as you can see, this is a triple point, which the at certain pressure and temperature discusses the presence of solid, liquid, and gas states of matter of a specific liquid that exist at the same time. And this one here, the triple point solution here, this is the boiling point elevation, by which one, as you can see here, gas with regards to the liquid, and the freezing point depression with regards to the liquid, gas, or the solid part. Okay, so at this one, we will go on to the boiling point elevation. And the equation for the boiling point elevation is just a delta TB is equals to KB, or the molal boiling point elevation constant, and the times the molality. So the concentration of solution that we will be using is a molality, and it's directly proportional to the boiling point elevation of the solvent. And as you can see here, guys, take note that this molal boiling point elevation constant is always constant. And as you can see here from this table, you will see the constants for it for a specific solvent. So this one, ayan, makikita nyo naman. And for the normal boiling point, tandaan nyo guys, makikita nyo yung part ng equation natin that it will always be added after solving the molar boiling point elevation of the specific solute. Now, this one here, ayan, for this one is actually freezing point depression and it's not a boiling point elevation. And as you can see here, it is denoted by delta TF subscript F. And KF is the freezing point depression constant times the molality. And as you can see here at the KF here, at every solvent, there's a specific value for the molal freezing point depression constant solvent. Okay, we will ma-appreciate ito kapag magka-calculations na tayo the next part of our lecture. So this one here, take note that these equations does not depend on what kind of solute is, but rather of the how many particles dissolved in a specific amount of solvent. And as mapapasa nyo nga, yung ating molality is based, di ba, moles per kilogram of solvent. So we will be tackling about these solvents. Solvents by which, siyempre, it has their own constant properties such as their normal boiling point, freezing point, and the constant values for molal boiling point and freezing point depression and elevation respectively. So these are just a calculation for this part, and we'll not discussing this one because we will discuss this on the next part of our lecture. And here is another colligative properties. Now, that the one that we discussed earlier for the molal boiling point here is a covalently bonded compounds, meaning that they are not ionic, they are covalently bonded, as you can see. Now, if we are going to consider, let's say, we want to calculate for the, those are non-electrolytes for another term, okay? The colligative property of electrolytes, when we say electrolytes, it exhibits a ionic bonding. So therefore, what are the examples of the electrolytes? Those are the completely dissociated in a solvent. Let's say water that tends to interact to the solvent and solute interaction. So magkakaroon tayo ng solvent and solute interaction. Now here, as you can see here, it will show a greater changes than those of non-electrolytes because of the, as you can see here, 1 molar of sodium chloride does not show twice the change in freezing point than a solution of methanol does. This is just an example of the negligible for the negligible property of the freezing point depression of the sodium chloride that exhibits on the solution. But the term that we have to consider is the Van 't Hoff factor. So the Van 't Hoff factor is a numerical value that is distinct for every ionic compounds. So ang mangyayari kasi dyan guys is, I'll just show you here. The Van 't Hoff factor, I hope na naka-show siya dito. I'm just gonna take a glimpse here kung naka-show siya. Okay, nandun pala, okay. So this one here, magkaaroon tayo ng addition dun sa may equation natin, which is the I term. Nakikita natin yun mamaya. So ayan, ang mangyayari kasi dito is that 1 mole of sodium chloride in water does not really give rise to 2 moles of ions, but rather some sodium chloride reassociates to one another. That's why the predicted value, the actual or experimental value for the value of Van 't Hoff factor is lesser, 2 times than the concentration of sodium chloride. Ang maaari kasi dito, let's say, sige, ayan. So as you can see here, association is more likely higher at the concentration. So ano ba yung mga Van 't Hoff factor natin na yan? Okay, let's consider this one. And kung mapapansin niyo for this one here, kung mapapansin niyo dito sa ating Van 't Hoff factor is ayan, kung mapapansin niyo for the equation of the freezing point depression is nagkaroon tayo ng I, which is I is the Van 't Hoff factor. And meron silang distinct value for every ionic compounds present. Let's say we have the sucrose. The Van 't Hoff factor of sucrose is equals to 1. Sir, bakit 1? Because sucrose is a non-electrolyte. When we say non-electrolyte, di ba, it has a formula of C12H22O11. na kapag na-dissolve sa water, it will not yield any ions. Somehow, the sodium chloride here, di ba, when dissolved in water, it will generate sodium plus chloride ion. So therefore, the bond factor value here is 1, is 2, because there are 2 ions present. But according to the here dito sa natin, dito sa ating experimental value, that the sodium chloride has only a value of 1.87 and 1.94 and 1.97 interaction. Bond factor value pala, I should say. Because ikaw anyong ASEAN, there is some reassociation na nangyayari between those 2 ions at higher concentration. So nababawasan. I forgot the term for that, but there's a term for the interaction between those ions. And that is not a reassociation, it's just a synonym, but there is an actual term for that. Okay? So ayun, discuss ko lang. Then for the sodium potassium sulfate, there are the bond factor of this is 3, because when it dissociates, it will yield a sulfate ion and 2 potassium ion, because K2 for the balance. And then for the magnesium sulfate naman, ang bond factor value nito I is equals to 2, because when it is dissolved, ayan, it will yield a 2 ions, namely the magnesium and sulfate. Dito naman is 3 kasi nga, ayan. And take note guys, that is, ang tinitake note lang natin dito is the limiting value. So yun yung tinitignan natin. Usually na sinasubstitute natin sa equation natin for us to calculate the colligative property of solution, let's say the freezing point depression. Later on, magkakaroon naman tayo ng calculation with regards to that. But as you can see here from the experimental value that ayan. So here, reassociation, ayan. So at dilute concentration of the solution, reassociation is not more likely to happen. And at higher concentration, it is more likely to happen. So that's it for that one. So we have to skip this part again. Okay. Now let's go on to the osmosis. Now, since we're done with the before pressure lowering, boiling point elevation, freezing point depression, we have to go. And our last colligative property of our solution is the osmotic pressure. But before we discuss the osmotic pressure, we have to be familiar first. I'm going to discuss first the principle of the osmosis. Now, in this osmosis process, it is just a process by which the solvent passes or goes through to the higher concentration of solute via the presence of the semi-permeable membranes. Now, here in biological systems, most semi-permeable membranes allow water to pass through, but solutes are not free to do so. And the typical example of it is that the red blood cells that we will later see on in this presentation. Okay. Now, this one here, this one is the concentrated solution and the dilute solution. And this one here is the semi-permeable membrane. But of course, since the dilute solution will tend to go to the here, the solvent will tend to go to the higher concentration of solute, by which, syempre, ang mangyayari dito is, the water will go from dilute to the concentrated. And the applied pressure stops the net movement of the solvent for the solution. So here naman, dito in osmosis, there is a net movement of solvent from the higher area of solvent concentration or lowest solvent concentration to lower solvent concentration. So ang nangyayari dito is from diluted to concentrated yung movement ng ating solvent. Okay? So ganun lang naman. Ayan, nakikita nyo naman, higher solvent, from higher solvent to the lower solvent. So ayan. So ang solvent yung nagmo-move, not the solute, because meron nga tayong semi-permeable membrane na humaharang sa may solute particles natin for them to not pass through in the solution natin. So ayan. That is the process of osmosis. Okay, next. Next, the pressure required to stop osmosis is also known as the osmotic pressure, which has a formula of moles per liter. Dito naman, kung kanina is molality ginamit natin, dito naman is molarity, which is moles per liter naman ginamit because we are considering the volume of the solution. So, applicable din dito yung Bancoff factor na I. Ayan, so it's just a kwan. Ayan. And I have to add this term that if the osmotic pressure is the same on both sides, that is a isotonic. So this is just a calculation. We will skip to this part. Now, let's consider this one. The osmosis, the typical biological process that nangyayari as may osmosis natin or osmosis process na nangyayari sa katawan natin is when, consider this in blood cells, okay? When the outside or the water matrix natin has a higher solid concentration, the water in the red blood cells will tend to move from the higher solute concentration. And mapapansin ninyo, magkakaroon tayo ng natin. Ang solution natin doon is ay hypertonic in a cellular perspective. If the solute concentration outside of the cell is greater than the inside of the cell, then it is hypertonic. When equal, that is in the state of isotonic. So water will flow out of the cell and crenation will result. And another one here, dito naman, the osmosis of cells. Ang mangyayari naman dito, let's suppose that our red blood cells has a higher solute concentration than its surroundings. Then, therefore, water will tend to go to the red blood cells. Kasi nga, di ba, tandaan ninyo, osmosis natin, ang movement niya is from diluted to concentrated. Tandaan nyo from diluted to concentrated. Kung saan mas maraming solute, take note the semi-permeable membrane, doon yung movement ng water natin. Ayan. So, kapag gano'n naman ang natin, when the solute concentration outside the cell is less than the inside the cell, the solution is hypotonic. So, mangyayari, water will flow into the cell. And mangyayari doon is hemolysis. So, ang typical example lang nito, if kunwari na-stuck kayo naligaw kayo sa isang sa gubat, so advisable ba na inumin yung ihi ninyo? I think it is not. Because ang mangyayari sa red blood cells natin or cells natin specifically is magkakaroon tayo ng hypertonic. Because yung urine natin has an organic waste and inorganic waste, which is we all know that is a saturated solutions as compared to our cells natin. So magkakaroon tayo ng osmosis. And ang tendency nun, mawawalan ng water yung cells natin for them to function more efficiently and magkaroon din sa yun nga, ang metabolism process natin. And again, this is just a calculation. We will skip to this part, but other. Ayan. And then, for the last naman, this is just a last topic. So, the colloids is just a suspension of large particles, individual ions or molecules, but too small to be settled out by gravity are colloids. So, ang colloids dito is yung hindi siya na-dissolve sa ating tubig natin. Okay? So, we have the dispersing medium and the colloids. Para ma-distinguish din yun, actually, meron akong lecture about the colloids for that. Colloids for that. And if you want to watch it, okay, I recommend you to watch it. So, nakadepende yun sa natin sa kanilang size. So, ito, makikita naman ninyo here, the phase of the colloid, the dispersing medium, and the dispersed substance. And in order to distinguish the solution, the colloids from the solution between the two, we have to use a light so that the colloid will exhibit a Tyndall effect or scattering of light. No, mangyayari doon, ayun, yung colloidal particles natin, mag-ini-scatter niya yung ray of light and you will distinguish. While the solution ay hindi niya ini-scatter yung light natin. So sa mga colloids sa ating biological system, we have hydrophilic and hydrophobic. Ang hydrophobic natin, that is yung mga fatty acids natin, doon naman sa may natin, yung hydrophilic is yung mga proteins natin because they contain a hydroxyl groups or carboxyl groups for them to interact with water. So, ayan. And putting concepts together. So I will skip this part, and that's the end of our lecture. The colloids, hindi ko siya discuss ng thoroughly because the scope of our discussion for our lecture is just the physical properties of solution and the colligative properties of the solution natin. So that will be our discussion for today, guys. See you in the part 4, I think, or the next part of our lecture, which involves the calculation of the colligative properties of the solution. So thank you guys for listening and have a good day. See you in the next part.